So section 10.3 is about looking at functions and their graphs and analyzing those graphs. Today is going to be about domain range and then also maximum and minimum values of functions. So to begin with, don't write anything down. I'm going to just talk about how you write domain and range. Here's a quadratic. I hope you're familiar with quadratics. What I do for domain and range is I'll start with my pencil for domain. I'm going to start with my pencil to the furthest left. The furthest left-hand point for this graph has an arrow on it. So this graph is, and it's not just pointing down, although it does look like it's pointing mostly down, it's also pointing off to the left. So this graph is continuing all the way to the left. And if I go to the right, it's also continuing all the way to the right. One way to write that is this graph is going for x coordinates. It's going from negative infinity to infinity. Negative infinity is less than the x coordinate, is less than infinity, is a way to write that as an inequality. Another way to say that is all real numbers, and your textbook prefers to write all real numbers. We're also going to look at interval notation in this section. Interval notation, instead of using those less than signs, we'll use parentheses. So this is not going to include infinity because you can't include infinity because it's not really a number. So the domain is going to be from negative infinity to infinity, and in interval notation, which you're learning this section, you use parentheses to show that. It looks a little like an ordered pair, especially when you have numbers in there, it looks like an ordered pair, but it doesn't mean an ordered pair. It means those are x coordinates. Those are the kind of x coordinates you can have for this function. For range, I always put my pencil at the lowest point. This lowest point has an arrow on it. It's actually a tie. There's a low point down here, but that one also has an arrow on it. So we're starting at negative infinity because the arrows are pointing down. And then at the highest point, there really is a value of -2. My y coordinate for that high point is -2. For range, I'm looking at the y coordinates. So here's the range as an inequality. Two ways of writing that inequality. One way is starting with that negative infinity, and the other one is just saying y is less than or equal to -2. This is the way that your book writes it. Actually, your book will not include the negative infinity, and I think Pearson will mark you wrong if you use the negative infinity. So be careful of that. In interval notation, you would write from negative infinity with a parentheses because you can't be negative infinity. And then there really is a value here at -2. So in our inequality sign, we have a bar under it. And in our interval notation, we use a bracket. So the bracket is like the less than or equal to sign, and the parentheses are like the less than signs. So we include the -2, so we use the bracket for that -2. Here's one more example. If I go for domain, left to right, the furthest left-hand point has an arrow. Furthest right-hand point also has an arrow, so the domain is going to be all real numbers, or negative infinity to infinity. And in interval notation, it would be the parentheses. And then from low to high, the lowest point has an arrow on it, so starting at negative infinity. The highest point is at -2, and there is a value, so I would use a bar under that. Again, your textbook prefers this notation, but I prefer the one above it. In interval notation, we would put a bracket around the -2 because that value is included. There really is a point with a y coordinate of -2. Okay, all of that was not meant to be written down, just take a look at it. This was something I would put in your notes, so please stop me when I'm done talking and you can go ahead and write stuff down. But first of all, the definition of domain is going to be all possible x coordinates for your function. The way you find it is you move your pencil from the furthest left to the furthest right, and you'll use x coordinates. You have to go from left to right. Inequality notation, it would be your furthest left-hand point with a less than sign, and then your x in the middle, and then your furthest right-hand point. In interval notation, we use brackets for less than or equal to's, and we use parentheses for less than. And you can have a mix. You could have a parentheses on one end of your interval and a bracket on the other. For range, it's all possible y coordinates. We go from low to high, and we use y coordinates. These are going to be, this would be your lowest y coordinate with a y in the middle to your highest y coordinate. Interval notation uses parentheses and brackets instead of less than signs and less than or equal to signs. Okay, pause here and write that down if you weren't able to keep up. I'm going to give you a chance to practice some domain and range. So I'd recommend pausing and restarting after you've tried these problems. And then I will talk through each of them. So go ahead and try this one, pause me, and then come back to me. So for the domain, this arrow is pointing off to the side a little bit. So the furthest left would be negative infinity. And the furthest right is pointing off to the right a little bit, so negative infinity to infinity. Again, your book says all real numbers. In interval notation, the way we write that is negative infinity, comma, infinity. For the range, it would be lowest point, which has a y-coordinate of -8. There is a value there, so we say less than or equal to. And then the highest point, there's a tie, but they're both pointing up, so then we do the infinity sign. Again, your book does not include that part, so your book might just say x is greater than or equal to -8. Either these two answers are equivalent. Your book prefers this notation. For interval notation, the bottom value is -8. That has a value, so we use a bracket, and then the highest value is infinity. Okay, here's a square root graph. For domain, the furthest left-hand point is 1. There really is a value there. The furthest right-hand point has an arrow on it. And again, your book prefers to write x is greater than or equal to 1. The interval notation would be a bracket at 1 and then infinity because it continues off to infinity. For range, the lowest y-coordinate is 0. The highest y-coordinate, this is pointing off to the side, but also up, so there's an infinity there as well. Again, your book prefers to write y is greater than or equal to 0. In interval notation, it would be from 0 to infinity. There is a value at 0. You can't have a value at infinity. Okay, here's a half of a circle. My furthest left-hand point is at -3. My furthest right-hand point is at +3. In interval notation, those are going to be brackets. My lowest point has a y-coordinate of 1. And my highest point is up here with a y-coordinate of 4. So I would use brackets because those are really points on my graph. There really is a value there. Okay, here's an exponential function. Domain, this is going further to the left. This is going further to the right. So the domain is going to be all real numbers. The interval notation for that is negative infinity to infinity. The range is a little bit different. This is flattening out. It's not going further down. This is a flattening out of the graph. Remember, this is an asymptote. So my range actually starts at -3, but there is no value, there's no point that has a y-coordinate of -3. And then my furthest highest one is pointing up, so it would be from -3 to infinity. Your book, again, prefers to write y is greater than -3. In interval notation, we write that with a parentheses because there's no real point at -3. And you, of course, can't include infinity. All right, that's domain and range. The next topic for this section is about maximum and minimum values. So these are going to be asking you about functions that you should have an idea of what the graph looks like. Here's a linear function. This is, again, one that you should watch, but I actually want you to pause this and imagine what this graph looks like. And then restart. I hope that you imagined a graph that started with a y-intercept of -3 and had a slope of 2. And I hope that you realize that that graph goes on forever in both directions. So this particular graph has no maximum value because the arrow is continuing to point up. It also has no minimum value because the lowest point is continuing to point down. There is no minimum value for this linear function. Okay, think about what this one would be. Here's an exponential function. I hope you said that there was no maximum value This time the arrow is getting close to 4, but since it never actually reaches 4, there's no maximum value for this function. There's also no minimum value for this function because that arrow is continuing down. Here's an absolute value function. Look at the highest point. The highest point, these ones are actually tied, even though they don't really look tied. They both have arrows on them. They're both pointing up. So the highest point, there is no highest point. There's no maximum value. It continues to increase. Now look at the lowest point. The lowest point is at 2. So we use the y coordinate when we talk about the minimum value. The minimum value of this function is 2. It's the y coordinate at the lowest point. This is the first function that has a minimum value that we've looked at so far. Here's a quadratic. Try to think about what a quadratic looks like. This would be a good one to have as an example in your notes so you can look at, so you can have something to refer back to. The vertex of our parabola would be at +1, -3. So it's going to have this general shape. This one has no max because the highest point is pointing up, continues to increase, but it does have a minimum value, and the minimum value is the y coordinate, so the minimum value would be -3. Okay, here's a square root function. Try to think about what that looks like. This is going to be shifted horizontally, but horizontal is horrible, so it's going to be at -1, and then it's going to have that square root shape. The minimum value, so the lowest point actually does have a value. The minimum is going to be 0, and the max, it has no max because the highest value is continuing up. All right, here's a cube root function. You got to remember what a cube root function looks like. This would be shifted, so -2 and then up 3. To the right we go up, to the left we go down, and so this cube root function has no max because the highest point is continuing up, it's continuing to increase. The lowest point has an arrow on it too, so this has no minimum value either. All right, this is what my notes look like for today. When I took notes on paper, I had some examples of domain and range. I also had that table for domain and range. And then I had some examples too for maximum and minimum. A big note that I put for myself is that maximum and minimum values are going to include the are going to be answered with the y coordinate. If there is a value, it would be the y coordinate. That's all for today. Now that your notes are done, you can do the 10.3a homework. Thank you so much.